0.3. That's what I want to do. So I want to now translate this table into a decision tree. That's what I want to do. So decision tree, first of all, you want to aware of two symbols. This rectangle means decision point. Right? And you have also circular like that, and that's a status, right? You have different options than or condition. If you have different choices to make, then you have to have this circle. That's what you are seeing, and um, so if you look at the same Excel sheet that I did, the first thing that we want to do is, we have to start. So we have to start from here, and we have alternatives. How many alternatives? We have to make decision, which one to choose from, right? And we know that there are three choices right here. We have three choices, and can I change the color? The first one is alternative one, right? Alternative one was build a small facility, right? That was the first alternative. And then the next line is A2. That's a medium facility, a medium facility, right? That was the second alternative. And third alternative is right here. And that is building a large facility, right? So you are having three alternatives. And we find that there are different choices to make. So we find that here we have choices to make, 1, 2, 3, because it says that now you have three different status. First one is, a high demand, and second is moderate demand, and then low demand. Similarly, here is high demand and moderate demand and low demand, right? So we have three choices to make. So I'm gonna change that now to this and say high demand. And here's moderate demand. And here's a low demand. And the table says the probability for that is high demand was 0.2. So 0.2 is there. And then here we have 0.5 is another probability, and low demand is 0.3, right? So that's what we learned from there. So, and we say this is a market condition. So that's what it tells us. And on the alternative 2, we have another three choices, three conditions we have. First one is high demand, and that's the same probability in this case. So, and moderate demand, MD, 0.5, and low demand, and that's 0.3. Similarly, if you go to the last one, then we have, if you are building a large facility, then high demand is 0.2, and moderate demand is 0.5, and low demand is 0.3. Okay, that's what you found. And then you have the money that you are making for that is connected to each status, right? So high demand 0.2, and it's building a large small facility. At the time, you're going to make $80,000, right? According to the table, that's what it says. And moderate demand, and it's building a small facility. Oh, I made a mistake here. So let's go back. I forgot about this. So that's confusing. So let's do this. So remember that this is a small facility, right? This is a small facility. So small facility, then high demand. Oh, this was right. $80,000. And if it is a moderate demand and small facility, then it's $60,000. And then if it's low demand and the small facility, it's actually loss of negative $10,000. You are losing $10,000. And look at this. So here we have medium facility, high demand, $60,000 and $40,000 and $30,000. And go with large facility, and you make $70,000 when it's high demand, high market, and $50,000. And lastly, $20,000 when the demand is low. That's what I find. So instead of the table, you may be presented with this kind of decision tree. And by looking at this decision tree, you have to now decide what is max, max min, and Laplace, expected monetary value, expected value of perfect information, expected value with perfect information. So these things can just come out, and you have to answer those questions yourself by looking at this. But don't be intimidated because it's the same thing, right? So the table you translated into this decision tree. Now you can translate this, convert this decision tree back to the tree, the table, so that you can easily calculate all these things that they are asking, right? So
I have a question.
Yep.
So for moderate demand, you have 0.5 there, correct? And then lower is 0.3, but then high demand is the lowest demand of all. Looks like. Is that correct, or am I reading it wrong?
Yeah, so the probability is only 20% for high demand.
Oh, okay, that's probability. Okay.
Yeah. Yeah, so this is probability. These are probabilities. So now, if you look for EMB, right, here is EMB, you are doing the same thing, right? EMB for this point will be 8.2 times 80,000, right? And then 0.5 times 60,000 plus 0.3 times negative 10,000. And that is going to produce the thing that I did for you. So EMB in this case, it has to be $43,000 over here. $43,000. And EMB for this, a medium facility, so 0.2 times 60,000 plus 0.5 times 40,000, and large demand 0.3 times 30,000, then you find that the EMB, so alternative 2, this is alternative 1, equals 41,000, right? That's what you see. And lastly here, EMB alternative 3. So 0.2 times 7,000, 0.5 times 50,000, 0.3 times 20,000, then you get $45,000 right here. Right, $45,000. So then, what is your ultimate decision here, right? So if you just go for EMB, right? If you are using EMB criteria, in this case, your decision, right? Decision point right here. And you're going to make the decision here, and you say, yep, if I go for EMB, the answer is alternative 3, build a large facility with EMB being $45,000, right? This is going to be your answer. So if you're using EMB, then this is going to be your answer in this decision point. All right, so that's how you are going to translate the decision tree and calculate EMB and everything and find it out. Let's go to this question. So this is from my OM lab, and can I ask Pat Agar to read this question for us aloud?
Sure. FJ Brewerton Retailers, Inc. must decide whether to build a small or large facility at a new location in Omaha. Demand at the location will either be low or high with probabilities 0.6 and 0.4 respectively. If Brewerton builds a small facility and demand proves to be high, he then has the option of expanding the facility. If a small facility is built and demand proves to be high, and then the retailer expands the facility, the payoff is $220,000. If a small facility is built and demand proves to be high, but Brewerton then decides not to expand the facility, the payoff is $183,000. If a small facility is built and demand proves to be low, then there is no option to expand and the payoff is $210,000. If a large facility is built and demand proves to be low, Brewerton then has an option of stimulating demand through local advertising. If he does not exercise his option, then the payoff is $40,000. If he does exercise the advertising option, then the response to advertising will either be a modest or sizable, with probabilities of 0.5 and 0.5 respectively. If the response is modest, the payoff is $25,000. If it is sizable, the payoff is $210,000. Finally, if a large facility is built and demand proves to be high, there is no advertising needed, and the payoff is $300,000. What should Brewerton do to maximize his expected payoff? Choose the correct decision tree below. Not all the payoffs are in the $1,000.
Thank you. So you don't have the choices here. However, this is from my OM lab, and you are going to use expected payoff, right? So meaning EMB method, not max or max mean or Laplace method. You are supposed to use EMB method right here. And the challenge here is that you have to draw a decision tree that reflects this description. So it sounds quite complicated, and it's not a little bit difficult and different from the previous exercise that we had. So let me give you about 3 minutes for you to draw this, and then I'm going to go over with you that I have. So first of all, the decision point is right here. And your decision is whether to build a small facility or large facility, right? So that's your choice to make. And after that, you have choice whether that is a high market or low turnout or high turnout. And if it is low, that's a 60%. If it's high, then 40%. And that's the same with large facility choice as well. So low 60% and high 40%. But remember that this is a condition, therefore it has to be circle. It shouldn't be a decision point or rectangle or square here. So that a symbol, you have to be careful. And then if you go further down, now if it is small and high market, then we have another decision point to make, whether to expand or not to expand. So we have two choices to make. So in that case, you have to use a square rather than a circle. So, and then if you expand, if you choose to expand, then that's $220,000. If you choose not to expand, then $183,000. Now, if you come to large facility, it's more complicated than before. So if it is high market, nothing to worry about. You are going to have $100,000 of payoff. However, if it is low market, then now you have a choice to make whether you are going to advertise or not to advertise. If you don't advertise, then your expected payoff is going to be $40,000. Now, if you do decide to advertise, then another condition is added to the question, that is whether it is a sizable advertisement or not, right? Is it a modest one or a sizable one? So you have to look at the probability. So therefore, it is a circle rather than a square, because now it's a probability. You have choices to make, and that condition is divided into two, modest or sizable, and 50% of chances are given there, and the expected payout out of that choice is $25,000 and $210,000. So now you have to calculate the EMB, right? EMB is easy here, 0.6 times 210 plus now expand or don't expand, right? So in this case, you have to choose the better one, and you know that expansion is better, so 220 will be your choice, and it comes there. So high market, I think your best bet is to choose to go with expansion, and 220,000 times 0.4. So your expected value of small plant in this case, 0.6 times 210 plus 0.4 times 220. That's your choice there, and that expected value is right here. Now for larger choice, 0.5 times 25 plus 0.5 times 210 is your EMB, and that comes over here. And don't advertise 40. I think this one is greater, right? So 12.5 plus 105.5, that's 120 something 5, and that will be your choice, and the probability is 0.6, and 0.4 times 300 will be your choice there. So this one times 0.6 plus 0.4 times 300, which is greater. So now you have EMV for this and that, and you have to choose which one is greater.